Hello, welcome back. Today, let's try to solve another Leetcode problem, 617, merge two binary trees. So, for example, we have two binary trees. This is the left side and the right side. We need to take care about the descriptions. So here said, some nodes of the two trees are overlapped. For example, this node 1 and this node 2 at the root area. So they are overlap. So we just need to use a new tree node. We need to use a new node. So this new tree node, the value should be 1 plus 2. So this new tree node should have a 3. Sometimes there's no overlap. For example, this 5 node and there's no node. So what we should do, we just need to take this node. The merge rule is that if two nodes overlap, then some nodes values up as the new value. So this means if they are overlap, just sum them as a new value because we need a new tree node. Otherwise, the not null node means this 5 is the not null node will be used as the node of the new tree. This means if there's no overlap, we can just use this node as the left side of our new tree. It's not this tree, this tree is built by a new tree. This means from here we have a 3, 4 and 6, 4 and 5. So this is our new tree. But at the left side, if there's no overlap, we just take this node. Because after that, it should always be true, no matter what values. Because we don't need to merge anymore, because at this area, there's no node. And similarly for this 7, because here we have a 7 at the right side for the root 2 for this tree 2, and here we don't have, so we just take this node, and from here we don't need to do anything. Let me go to the whiteboard to explain, because normally for the tree data structure, even it is an easy problem, you need to understand the basic recursive function, how it is returned, and how is the function calls to call these merge trees at the left side and the right side. Now let me go to the whiteboard to explain. Normally we have two situations. For one situation, it's totally the same. It's complete. It's a balanced binary tree. For example, this is 1, 2, 3. This 2, 1, 3. Basically, it may be balanced or not balanced, but basically, we always have the node always be overlapped, like the root left side and the right side always be overlapped. Another situation is, there's no overlap, maybe at the left side from here, or maybe at the right side from here. Now let's go to the first situation. Why we should do like this? Because for binary tree, for the tree merge, or the tree data structure, basically we need to write the recursive function. And for this recursive function, we need to find the return at which condition we need to return which value. So this is an easier example. So for this example, if we write our merge tree function, we need to find a return first. But before we write this return, let's write our main function. So what is a root? We should first have a root. So we need to build a new root. So this root will be tree node, and inside will be root1.val plus root2.val. Because of this situation, we always have the root1 and root2. When it comes to none, we always have the root, this left side to none, and this left side also to none. It means basically the structure is exactly the same. So from here, it means we always have the root. So we build a new tree node. So root1.val plus root2.val, it is 3. Then we go to the left side and the right side. So from the left side, what is that? Root.left, it is this one. Self.merge, it is merge trees root1.left and root2.left. So we're going to merge this node at the left side and this one, node 1 at the left side of the root 2, this tree 2. So how we gonna merge? So here we have a node 2, here we have a node 1. So we call our recursive function, and this one we will ignore it at the moment. We just use another root. So this root will be tree node root1.val plus root2.val. It means from the left side, root root 1 dot left dot val, root 2 dot left dot val. So it means it is 3. 2 plus 1, it is 3. Yeah. So it means here we're gonna have another node. It will be 3. And then we continue to call our function. So what is the function? We're gonna yeah. So this is the root is 3. Then root to the left. So the root dot left is the self dot merge trace. Root dot left. So here it means root dot left. It means here at the left there is none. Root 1 here it is none. So it means from here we're gonna write our return function. What are we gonna return? We just need to check if not root 1 and not root 2. Yeah, this is basically the root 1 dot left, root 2 dot left after 2 function calls. Yeah, because there's nothing, so we're gonna return a none. So from here, we just return none. Similarly, for the right side, we just plus those 2 values, it is 6. Yeah. Finally, we just return this root. So this is our root. So this is an easy case. So when it comes to difficult, yeah, maybe more difficult case, it is like this. So we have a tree structure 1 and 3. At the left side, we have no node at the left side. Here, we have another node. Yeah, basically, from here, it's the same from the tree node area. So we're going to have a 3 for our new tree node. So we're going to have a 3. And then we go to the left side. If we go to the left side, we're going to check this left. So from the left side, there's nothing. So this is a none. And for the tree 2, at the left side, there's a node 1. So here, we go to our function calls. So this is our next function calls. Imagine we here only have this line. We don't have those 2 lines. Yeah, we don't have those 4 lines, but we have the first 2 lines. And then we go to the left side. So here, this root is 3, and then we go to the root dot left. So inside it is root 1 dot left. It is a none here. Yeah. So inside the function calls there is a none. At the other side we have the root 2 dot left. We have a node 1. Yeah. So this means from here we need a function return. So what is the return and how to check it? So in the function calls, we just need to check if not root 1, if not root 1, it is here. It means there's nothing in root 1. If not root 1, we're just gonna return root 2. What are we gonna return? We just return this one, root 2. It is this one node. Yeah, and then we go to the right side. It's the same because we always have the 3 node. This node we have and this node we have. We're just gonna sum of them and 6, and then we just return our root. So this is the root. So this is why we're gonna, because for tree data structure it is a symmetric. So here if not root 1 return, and here if not root 2 return. It's basically the same. Here to return root 1. Yeah, because it's symmetric. So here for this function calls, yeah, we just need to use this kind of a method to find the function returns for our recursive function. Yeah, now let's go to the code editor to finish my coding. So basically we're gonna first check if not root 1 and not root 2, we're gonna return a none. Then we're gonna check if not root 1, we're gonna return root 2, and then if not root 2, we're gonna return root 1. After that, we just prepare our root. So we're gonna define a variable root as the tree node. So this is the new tree node. So we're gonna prepare a new tree node because we already prepared the class tree node. So we don't need to this kind of code. But inside we can just use the values. So it should be root 1 dot val plus root 2 dot val, And then we're gonna go to the recursive function. So the root dot left should equal to self dot merge trace root 1 dot left and root 2 dot left. Similarly, we're gonna write the root dot right. Let me just copy this line of code and change the left to the right. So here gonna be the right and root 2 dot right. Finally, we just need to return the root. Yeah, basically this is the entire function. Now let me run it to check if it works. Yeah, as you can see, it works. So for basically for this kind of data structure for trains, we have to practice, and then it should be easier. Yeah, as you can see, it works, and the time complexity is the number of the nodes in the tree. Thank you for watching. If you think this is helpful, please like and subscribe. I will upload more Leetcode problems like this. See you next time.